Hello and welcome to Easy Projects. So today I will talk about this Imax B6 multi-charger made by SkyRC, except that this one is not made by SkyRC because it's a fake. So the specs for the genuine charger is actually pretty good. It will do up to 6 cells of 3 different types of lithium batteries, NiCad and nickel metal hydride batteries up to 15 cells, lead acid batteries 2 volt to 20 volts. It can charge from 0.1 amp to 5 amps, and it can discharge as well, up to 1 amp of discharge current. It has a nice 16 by 2 character LCD display, so you can monitor the charge voltage and current, and you can see the time that you've been charging or discharging for. And it is a balanced charger. So if you have multiple cells, it will monitor the voltage of each cell and make sure that none of them are being overcharged. So these two are the main current outputs, and these will ensure that each cell will get the same charge. The only negative thing I can find about the real charger is that it doesn't come with a power supply. You'll have to supply that yourself. But it does take from 11 to 18 volts though, so it should be fairly easy to find something that will do the job. It will need to be 5 amps though, so they are a little rare. But they do make a version with the power supply built in that's just a little bit wider. But let's get back to why I can tell that this is a fake charger. Well, there is some very obvious ways of telling it, but I didn't know of any of those when I bought the charger, so we will get back to those later on. This charger has a spec of plus minus 0.8%, so that means it will charge a lithium-ion battery to 4.2 volts plus minus 0.8%. So geeky as I am, I set up a test when I charged the first battery to check the spec of my actual unit, and I was in for quite a surprise. So let's just redo that experiment. So I just soldered 2 wires to a lithium-ion battery. It's a 3.7 volt type, and I added 2 sense wires here so we can monitor the voltage with the multimeter. So let's charge up this battery and monitor what will happen. So I have plugged in the battery, and let's start up the multimeter. And this battery is sitting at around 4 volts. So it is not fully charged, but there is some charge on it, and it shouldn't really matter for this experiment. We only need to see if the charger will overcharge or undercharge the battery. So let's turn on the charger. And it lets you select the program, and this is it calls it a LiPo battery, and for this charger that is the 3.7 volt type. And the lithium ion in this charger is a 3.6 volt type. But since this is a 3.7 volt lithium ion battery, we will select the LiPo. And we select a charge, and we have to set a charge current. Half an amp will be fine for this test. And it's a 3.7 volt. And this will only increment in the number of cells. But it will take 3.7. And it will just check that it agrees that we have set the correct settings. So you can't, oops, I was too slow there. It's just so you can't say it's a 2 cell when you only put 1 cell in there and then blow up the battery. But anyway, we have started the charge, and we are charging at a constant current of half an amp. And we can monitor the voltage here, and you can already see that this voltage is far off. So I will just skip a little bit until we get close to the 4.2 volts, which is the maximum. The 3.7 volt is the nominal voltage, and that's a maximum of 4.2 then. And we have got up to 4.18 volts now, and we really wanted this to stop at 4.2 exactly, but I don't think that's going to happen, because if you look at the charge it says 1.13 or 1.15. Oh, well, I know it's not going to stop at 4.2, but I didn't want to spoil the fun. And so we reached the 4.2 volts and we're still charging. Well, there is a bit of a safety margin on these batteries, so it will allow a little bit of overcharge, but generally at about 1% overcharge the battery starts to take damage. And that is due to the internal chemistry of the battery. When it's charging up and discharging, there's some oxidation and reduction going on inside the battery. And the problem with overcharging the battery is that the lithium cobalt oxide will actually turn into just lithium oxide, and that is irreversible, so it cannot get back to lithium cobalt oxide again. And if you continue to overcharge the battery, then it will turn into elemental lithium and carbon dioxide. And since carbon dioxide is a gas, that will be a whole lot less denser than the compound in there, so it will start to expand, and when it expands it will create a pressure, and at some point the battery will start venting or explode, and that will most likely start a fire. And that is considered a bad thing. And you can see right now we actually exceeded the 1% overcharge. But this is a very bad eBay battery anyway, so I won't mind if it takes some damage, so we can just let the charger do its job and see where we'll be sitting at when we're done. You can see it actually entered the constant voltage charging mode now, so now it's only drawing 0.4 amps. So let's actually put the multimeter into min-max average mode here. So we can see the maximum charge and minimum charge, and more importantly the average charge. And you can see both the maximum and the average charge just keeps getting higher and higher. And when the charger drops to about 100 milliamps of charge current, I'll just reset the average, so we will get a fresh value. So now the charger says that the battery is full, and yeah, I bet it is. It charged it up to 4.268 volts. So that is 68 millivolts more than it should have been. Well, the average dropped off a bit here because I was too slow to stop the multimeter, but I'll just put in a frame from when the battery charge axis said it was full and stopped charging, and that will come here. And here is just a live shot of the last part of the charge, and you can see if I stop the charger, there is actually still a good deal above the 4.2 volts on the battery itself. It will eventually drop off and settle at around 4.18, 4.17 volts or thereabout, and then slowly drop off to about 4 volts, but that will take much longer. But the initial drop here is quite fast. So now that we got disappointed once, let's see if we can make that even worse by measuring the charge current. Not that it really matters that much, but yeah, let's try to do that. So we should still see half an amp of charge current, and it is slowly ramping up. Oops, but it stopped at 465 milliamps, so that is also a fair bit off. But I don't actually know the spec for that, so at least it is on the low side, so I guess that's probably okay. Well, it is jumping around a little bit though. So, as I said in the beginning, I didn't actually know that this was a fake charger when I bought it. And I also paid about as much as the genuine one would have cost, so I will of course inform the seller that I'm not quite happy with this one. So when I noticed that this charger was overcharging the batteries, I went and did a Google search, and I found more fake chargers than actually real chargers. And if I would have looked here on YouTube, there's actually a lot of videos showing these fake chargers and how you can tell the difference between a fake one and a real one. And apart from the overcharge on my charger here, the display is actually not flush with the casing. It's a little further down in this side than this side over here. I don't know if the genuine ones would be like that. And also this button, the increase button here, is a little dodgy. You have to kind of press it really hard for it to do any good. But the real obvious thing is on the back here. The genuine SkyRC chargers have a validation sticker with serial numbers and validation numbers, so you can go to their website, plug those numbers in, and confirm that you actually got a genuine unit. And I'll just put a picture here what the sticker should look like. So I don't recommend you to use a fake charger like this one, and I will try to get my money back so I can buy a genuine one, but I don't know if I'm gonna get that. If not, I will maybe take it apart and see if there's anything we can do to increase the accuracy. But yeah, even though lithium-ion batteries can be dangerous, I don't think this is overcharging them too much so they will explode or anything, but it will indeed shorten their life. Well, so it is a shame that this is a fake unit, because I actually really liked it until I noticed that it was overcharging the batteries. And I am pretty sure that the genuine SkyRC one will not overcharge the batteries, because that is one of the worst things that a charger can actually do. Anyway, if you liked the video, please give it a thumbs up and subscribe to my channel. And I will be back soon with the video where I should actually have used this charger, because I am working on something where this would have come in handy. And I guess I could actually still use it. I will just have to monitor the cell voltage by myself, and yeah, I could probably do that. So, see ya.